What's up, Hobbyist? Welcome to my YouTube channel. In this tutorial, I'll be teaching you on how you can get several colors from RGB LEDs. The microcontroller I'll be using for this project is Arduino Pro Mini with a FTDI parallel programmer. Do you know you can get more than 180 colors from RGB LED? Let me show you how. On the screen is the circuit diagram of the project, and I've provided the pinouts of the RGB LED to make your connections easier. This is Arduino Pro Mini. The Arduino Pro Mini is a microcontroller board based on Atmega 328 chip. It has 14 digital I/O pins, of which 6 can be used as pulse width modulation outputs. It also has 6 analog inputs and a reset button and holes for mounting pin headers. A 6-pin header can be connected to an FTDI cable to provide USB power and communication to the board. The FT232 is one of the most commonly used IC to convert USB signals to UART signals. This process is very handy in a way that it allows you to communicate with and also upload code to an Arduino. We are also going to need female pin headers to attach the Arduino Pro Mini to the perf board, and also a couple of RGB LEDs. We are going to need a perf board, which I measured the size of the perf board to a size that is needed for the project and cut it out as measured. I inserted the female pin headers to the male pin headers that are already soldered to the Arduino Pro Mini board. Then I inserted pin headers into the perf board with Arduino board. I soldered everything on the perf board. Mind you, the Arduino Pro Mini can be detached from the board. I took the hot glue gum stick with reasonable length. Then I made a hole in the gum stick which is wide enough for RGB LEDs to fit in. So I inserted the RGB LEDs on either side of the gum stick. The circuit diagram provided can serve as a guide for the whole project. The power source for the project is FTDI programmer. Having fixed the RGB LED on either side of the gum stick, I cut the gum stick into 2 equal parts. Then I tested the RGB LED on either part to confirm they are working perfectly. After confirmation, I inserted the RGB LED into the perf board at the side of the Arduino boards. I soldered them to the perf board and I made sure the excessive pin outs were cut off. I bent the gum stick into love shape, but due to tension on either side, I added another support in the middle, which proves to work perfectly in neutralizing the tension. I connected the LEDs together in the correct way. I checked the pinouts correctly to make sure that they are connected accordingly. I also made connections between the RGB LEDs and Arduino Pro Mini using jumper wires. Then I inserted the FTDI programmer into the Arduino Pro Mini to establish serial communication and power supply. I opened up my Arduino IDE. I click on File, then I click on New to create a new file. I wrote a basic LED blink operation. Confirm the variables in the program match the color of the RGB LEDs. If you are not familiar with how you can blink an LED, you can go to the description below. You'll find my previous tutorial on how you can blink an LED using Arduino. It may not be a great habit to you, but I chose capital letter words with names of 3 colors. Then I initialized the digital pins as output. To make the code simpler, I created a function blinking each colors. I saved the file. You can choose your preferred name to save the file weight. Arduino will do a great job to make sure it corrects you in any form that is not acceptable. The next step is to choose the board type, which is Arduino Pro Mini. Then I chose the processor and power rating from the drop down at the tools. So if you are not familiar with this, also you can check the description below. In my previous tutorial, we'll see everything there. I then proceeded to choose the COM port and programmer. So I tested each primary color. To get more than just primary colors, I wrote another function that will handle mixing of primary colors to get about 180 colors. To make this work, the function has a way of handling the brightness of the RGB colors. The brightness ranges from 0 to 255 using analog write function. You must have heard of digital write function. You can check it out at the description below on my previous tutorial. Digital write, either the pin will go high or the pin will go low. But in analog write function, you can choose whichever brightness you want it to be. So which means 0 brightness means the LED will be off, and 255 as brightness means that will be the brightest value the LED can actually attain. So which means you can have any value between 0 to 255. So which means instead of high, you can have either high from 1 to 225, and low you can have 0. So which means the 0 is off and 255 is the brightest. So to get different colors, we need to mix the primary colors in a definite proportion. The secondary blend function has variable depending on the colors. For example, purple has 100% red, 0% green, and 100% of blue. Which means from 0 to 255, 0 is 0% and 255 is 100%. So how did I come about this? Let me show you how. I was fortunate enough to come across this website, www.downtownuplighting.com. So you will see the link at the description below. So you can browse through the website and check out different colors and their RGB combinations. For example, brown color has 65% of red, 16% of green, and 16% of blue, which can be calculated as a percentage of 255. 65% of 255 is about 166, and 16% of 255 is about 41%, which is for green and blue in case of brown color. You can have about 180 different colors from this website. There you have a beautiful and colorful display. Have fun coding. Thanks for watching. Don't forget to like my video, share, subscribe, and also hit the notification bell so that the next time I post a new video, you'll be the first person to get it. And also let me know what you think about this tutorial by making your beautiful comments below. And if you have any suggestion for me, let me know too. It will go a long way for me. Don't forget, I'm just an hobbyist. You can also follow my Facebook page, Instagram, and also on Twitter. Stay creative and see you next time.